Forests are great, but what if you don't have the tree type that you want? Well, this forest right here is made completely modularly using PCG, and I'm going to be showing you exactly how I made it using just a simple trunk, a branch, and some leaves. And we'll go over how to do things like tapering in the branches as it goes up, as well as shrinking the actual foliage in size as it reaches the tip, and having the ones on the insides bigger, so things go ahead and scale based on distance and everything. So with that, let me show you how it's set up. To get started, we're going to need a PCG graph. And for that, of course, we need to turn on PCG by going to Edit Plugins, searching for PCG, and making sure Procedural Continuation Framework is turned on. And we're also going to need the Procedural Continuation Framework Geometry Screen Interop. Make sure both of these are turned on and go ahead and restart your engine as needed. Once you have restarted, we can go ahead and get started. Just go ahead and right click, go to PCG, and grab yourself a PCG graph. I'm going to name it PCG underscore modular forest. And I can already drag this out into the world, and this will be our kind of area where we're going to have the forest. You can absolutely set it up with a spline or anything else. I was making it simple and just using a volume for this. And go ahead and open up the PCG graph. So the first thing we want to do is sample the landscape. And not only do I want to sample the landscape, I want to make sure that I only select the points within the bounds of my volume on the landscape. And I want to filter out any of the harsh slopes that are further up the mountains because I don't want it spawning trees on the slopes in case I put the volume there. So what I'm going to do is right click and get landscape data. And if I just have it selected and press D, you can see the entire landscape turns white because, well, it is putting points quite densely, and we don't need this much. So what we're going to do is from the landscape data, I'm going to use a select points node. This will give us a little conversion, and I'm going to leave this select points node by default at 0.1, so it's going to keep only 10%. As you can see, this is 10% of the remaining points, which is considerably better. You can, of course, control the density of it at this point, because if you're depending on your trees, you might want to have more or less. But while I am going to be hard coding these values, you can just set up parameters and plug them in so you can control these dynamically for yourself. So great, we have the select points, but it's going everywhere. What we want to do is right click and get actor data. And we also want to use an intersection node. So I'll drag out of the select points and search for intersection. And then we want to get the actor data and plug that into source one. And if I press D on intersection now, you can see it is now only within the bounds of this area. If I go ahead and move it, it will regenerate. I can move it somewhere else and it will regenerate. Now, some alternatives you can do is to just generate the points in the volume and then project them onto the landscape. That way you don't generate the entire landscape. This is just a different way of doing it that I haven't shown on the channel, which is why I'm doing it this specific way. But just know there are other ways of accomplishing the same thing. From the intersection, I'm going to drag out and search for normal to density. Under spatial, normal to density right over here. We're going to have it selected. And in the normal to density, we can just leave it at default. It's just going to set all the points from 0 to 1 based on if they're facing upwards, which is set right here. And then from that, we can just use a density filter, and we can just set the density filter to be something like 0.95. So a majority of the points selected will be actually just facing upwards. So if I go ahead and sample this, and then I move it over here where the bounds are, you can see it is avoiding the nice large hill. But if this is, not steep for you want trees on something like this, you can change this 0.95 to something a little lower, let's say 0.9, and you can see it goes a little bit further up, and it all depends on your setup of how steep do you want these points to be. So now that we have the points where we're going to be spawning the trees, we got to, well, start spawning the trees. We're going to start off with spawning the actual trunks, and then we're going to spawn the branches, and then the leaves. To spawn the trunk, well, that's pretty easy. We just drag out, search for static mesh spotter. We'll add a mesh entry here, and we'll go ahead and open it up. And in the static mesh, I'll search for my trunk, and I'll go ahead and select it. And immediately you can see there's our trunks all placed around. Great, we kind of got what we want. Well, that part was easy. Now, how do we get the branches? We want the branches to, first of all, be not on the floor. We want it to be a certain amount off the actual ground level because we need to be able to walk under it, and normally trees have a trunk before the leaves start spawning. Not all types, of course. And we also want to have it be random in its height, so they're not all consistent. And we want to taper all those branches in. So let's take care of all of that right now. Now to do that, we're going to use a node called Mesh Sampler. Now it's going to throw an error at you at the beginning, but that's because it has no static mesh plugged in. So we need to get that. Now we can't just directly plug this in super easily. So what we can do is in the static mesh spawner, we need to change the out attribute name, and we can just call it trunk. So whatever mesh is being spawned here will be outputted to trunk. So what we want to do is drag out of the static mesh spawner and search for point to attribute set under parameters. This will convert to an attribute instead of a point information, but we want to just get the information we want. Now, technically speaking, if I press A here, you'll see it just has the trunk information, because at this point, we've only added the trunk information that is separated from the points. So we could just do this, honestly. Now, the one thing that you will see here is I get a warning. Multi-entry attribute was found on the override pin static mesh. Will only use the first entry to override. I'm not setting it up with multiple trunks, multiple branches, and multiple leaves. So in my case, using the first one is just fine. If you wanted to use all sorts of ones, you might need to do a loop and use a partition on mesh. I have other tutorials on the channel showing how to do this, so I'm not going to go through it right now, but just know that you can absolutely use multiple. You just need to make a slight tweak. But if this warning bothers you, what you can do instead of this is drag out and search for get attribute from point index. The input source will be trunk, and that will go into the static mesh, and it'll go from index 0. So you can see now it only grabs the one from the first one and then uses that. So either one should work. But once we have done this, it has effectively sampled the static mesh. So if I go ahead and press D on this mesh sampler, at origin, you will see all of these points going up as it samples the trunk here. See, it goes from the bottom and goes all the way up, the same as it does all of this stuff. So now we just need to copy it onto the points that it had before. So we'll just drag out of here and use a simple copy points. And we'll copy the points from the mesh sampler as the source to the target of the static mesh spawner. And now if I sample the copy points, you'll see each one of these trunks now has all of these points going from the bottom all the way to the top. The one thing I want to change though is all of these trunks right now are all the same height. So let's go ahead and adjust that now. And we can do that right before the static mesh spawner. We'll add a transform points node and we'll plug it in just like so. And we'll have it randomly scale between 0.5 and 1.5. And it'll also rotate the trees randomly 360 degrees. And if I resample the copy points node, you'll see even though they're scaling up and down, it still follows the actual geometry just fine. It has no issues with this. That's great. It gets us what we want. But now we want to filter it from the bottom to the top. We want to get a gradient going. And to do that is honestly quite simple. From the copy points node, we drag out and get a distance node. Now, if I right click and search distance, it is the first one selected. So you grab the default one, but just know there's also a distance node here, which is a different distance node. This is the vector distance versus regular distance. We want the regular distance. And we want to check the distance from these points to the original one. So they're going to come from the transform points here. I'll just drag it all the way through. The reason I'm not selecting it from the static mesh spawner is because the mesh spawner points are the actual mesh itself, not where they've actually stored it at. So the bounds are different and locations are slightly different. Now on the distance node itself, the attribute can be distance, that is fine, but we want to make sure that set density is turned on. That is very important. But if we look at it now, well, it's all black. It is pretty much all black going all the way to the top. Why is that? That is because we have the maximum distance set at 20,000. So effectively, it goes from 0 to 1 at a 0 to 20,000 range. And our trees are not 20,000 units tall. My trunk here is 803 units tall, approximately. So we'll use something around there. We'll change the maximum distance here to 800. And now if we take a look, the bottom ones are black, and the top ones come closer and closer to white and eventually become white. Now, this scale, keep in mind, is actually not relative to the scale of these objects. It is world space. What do I mean by this? Well, if I go back to the transform points, and I, instead of changing from 0.5 to 1.5, I change it to 0.1 to 0.2, so they're very tiny trees. You'll see if we take a look at them, there's the points, and they're all black, all the way up to the top, because in world space, it is that tiny. And for our purposes, this is fine, but you could absolutely do some math and also offset the value of the distance by the scale. So just a heads up. And if you're wondering how do you use loops because you haven't learned how to use them yet, or you're earlier on in the PCG journey, I do have a basics of loops video right over here you can check out to kind of figure out how to actually set up loops and use them for yourself. But assuming you're happy with the actual current distance and everything else, we just drag out of here and search ourselves for an attribute filter. And the target attribute, instead of last here, we want to select density. because we want to modify density, and we're fine with having it greater than, but we want to filter it randomly. Because as I mentioned before, we don't want to have them all off of the ground evenly. We want to have them kind of in a range where they start a little bit up and down. So from the distance, we'll drag out and search for attribute noise. This allows us to do a simple noise. And in the settings here for noise min and max, you can leave noise min at 0 and set noise max to 0.2. So as long as it's greater than this random value, it'll go ahead and select inside the filter. So if I just plug that in, should be good to go. But the amount of points here will be very high. So immediately I'll just drag out and do a select points node. This time I'll leave only half of the points at 0.5. So if I press D and I go ahead and take a look at the points, you can now see the bottoms here are no longer being selected. They don't go quite as far. Now this one is right over here. This one's considerably lower. There's a few more that's kind of in between, and we're still left with all the other points here, but there's just half of them now, which is a lot better. So from here, I'm going to drag out and grab ourselves a transfer points node. So we'll need to transform the points a little bit. And then we'll go ahead and use a static mesh spawner, where I'll go ahead and add a mesh entry, and I will select my branch that I have. And immediately you'll see it looks like blades. Why does it look like blades? Well, that's because in my case, the actual branches just were not rotated in the proper way on export, and so they're sideways. But that's okay, we can adjust that. I'm gonna rotate them in X by 90 degrees, both for min and max to get them in the right direction. And because they're kind of sideways, I also end up needing to rotate them along here so they're a little more random as well in how they're kind of spread out. Because right now, while they're random, they're not random enough, let's say. What I'm going to do is rotate it from -20 to 20 on the Y. If your branches are pointed in the correct direction, you'll be scaling Z. So that's great, but man, this does not look good, does it? Because all the branches here are the same scale all the way up, and we do not want that. We want to have these scale, well, inwards as it goes up. And we can do that. That's actually relatively simple. All we need to do is right-click, search for execute blueprint, and then in the blueprint element type in the detail panel, we can just search for scale by density and go ahead and select it. In the detail panel, you can see scale min, scale max. Keep in mind, both of these are set to 0 by default. So if you just plug it in and don't change anything, you will just not see anything. So be careful of that. What we want to do is scale minimum to 1 and scale maximum to 0.3. That should be a bit small enough near the top. We can go even 2.2 to get a bigger taper. The reason minimum is 1 is because the bottom of our trees is 0 density, so it's the minimum, and the top of our trees is 1.0, which is the maximum. So I'll go ahead and plug that in right after the transform points here and right into the static mesh spawner. And immediately, look at that. We have a nice taper here. And you can see the taller ones kind of straight out here. And this is just the one small problem of having it scale above 1.0 for our distances. What we can absolutely do is go to the beginning here in the transform points for the trunk and tell it to never scale above 1.1, let's say. And now we kind of get back the normal scaling of this. Even on the shorter trees, they just end on a kind of wider point. So now we have to do the leaves. And honestly, the leaves are a lot of just a copy paste from what we just did. Because we'll do the distance thing again, we'll filter it by distance, and pretty much all the same similar things. So because it's all the same, I can pretty much just take all of this and duplicate to the right. It's that simple. The only things we need to do is on the static mesh spawner here, we just set the out attribute name. In this case, we'll set it to be branch. And in this get attribute from point index, we'll also select branch instead of trunk. And we'll plug this in like so. The static mesh spawner goes all the way to the target. The distance comes from the transform points node, just like before. I'm going to change the select points density here from 0.5 to something really small, like 0.075. And honestly, this might be a good thing for you to change first before plugging in the things earlier. Because if you don't change this, you leave this at 0.5, you will get a lot of branches. And depending on your power of your hardware, it might freeze for a little bit or potentially crash. So you want to tone down this number early on. And the other thing I'm going to change in the scale by density, I'm going to change it to be from 2 at the minimum. So I want to have actually be scaled bigger. And of course, in the static mesh spawner, we want to change it to be from a branch to the leaves that you have. Now at this point, you will have trees that are extremely dense still. And we want to significantly reduce the amount of points here. So we're going to change this attribute noise a little bit. We're going to change the minimum here to 0.2, and we're going to change the maximum to 1. Now, setting it to 1 means that the branch could be entirely bare with no leaves at all. Now, whether or not you want this is up to you. The 0.2 means, based from the trunk, the inner little bit will never have leaves spawned on it. So if you don't want leaves spawning right next to the trunk, that is where you adjust this noise minimum. We have the maximum distance still set to 800, which assumes these branches are as big as trunks, so most of the values will be very low. In my case, the branches here are 113 units in length, so for a distance, instead of 800, I will set it to be something like 100. And because we copied the transform points, we still have the 90, 90, negative 20, 20 that we had before. So this negative 20 and 20 are fine, but we want to change the rotation here from negative 20 to 20 on X as well. Now, this way you want to tweak the values however you'd like. For example, I've changed the noise min and max for 2.2 and 0.7, so we don't get pure naked branches anywhere. But if you leave it at 1, you will. And if that is something you'd like, you of course have the control for that. I've changed the point ratio to keep a few less points. And the scale by density, of course, is from 2 to 0.35 to have slightly bigger leaves at the actual ends of where we need. And this is what we're left with. We can absolutely increase or decrease the amount of foliage we get for these trees, but all of them have mostly something somewhere along the branch. If we filter out less points, of course, we'll get bushier ones, but we have a nice variety of trees here now. You might be wondering, why do this? Why do this modular setup for the foliage? Why not just use trees, assuming that you have them already? Well, the actual trunk, a branch, and a leaf, in terms of hard drive space, is very low. And maybe you do have the performance to have all these instances around, but you're trying to limit hard drive space. In which case, this is a good way of doing it. Of course, if you don't have the trees, this gets you a way of creating those trees through different parameters that you might set up, and then you can use that to get kind of the look and feel that you need, quite simply. This, of course, is not the one way to do things. This is just a way to do things. And of course, the project file for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. If you'd like to join the community, link to the Discord will be down in the description as always. If you need a little more experience in like loops and other things that I mentioned but I didn't show, check out this series right here that I go over to create a full building with interior, all using the power of PCG.